Hello, cherubs. This is the Barker past paper we've been doing. We're getting down to question 14 now, which is a spicy little number. And it's a relatively easy one. It's just a one marker, this question. And it relies on this concept here. So here I've drawn the graph of using Excel of sine of x on x. That's this blue one in this relatively short domain. Or sine of 2x on 2x, which is this pinkish red one here, or sine of 3x on 3x, which is this little green number here. And you can tell as all these graphs get closer and closer to 0. So as x approaches 0, then all these graphs here approach 1. And that's what this big complicated little box here is. So the limit as x approaches 0, so as x gets closer and closer to 0, sine of ax on ax, so there could be, x on x, or it could be 2x on 2x, or 3x on 3x. Just this number here has to be the same. That will equal 1. Beautiful. So that's the principle that we're going to be using for this question. And then there's just a nifty little trick that we've just got to remember, just a bit of an algebraic trick. So what I want to show you is, so you can tell that this here is sine of 3x on 5x. Beautiful. So that's what we've got here. But you can tell that to use this formula, it will have to be like sine of 3x on 3x, because all of these are in the form where the argument, or the thing that's in here, this sign of what's in the brackets here, is the same as what's on the denominator. So we've got to make this bottom a 3x somehow. Alright, so that's our goal. So what will we do? So another way of writing this would be sine of 3x on x times 1/5, wouldn't it? Because if we times this by 1/5, times this by 1/5, the 5 is just going to go here, and then that's what we had over here. Beautiful. Right. So another way of writing this would be, so if I go sine of 3x on 3x, okay, so I've just popped a 3 there, so we're going to have to get back and rectify what I've done just there, and change it, but we still had the 1/5, right? Now what we've got to do, so we've times by 1/3 just here, timed everything by 1/3 just to get this 3 here. So if we times by 3, that will cancel, because we'll times by 1/3, and then we're timesing by 3. So that means we're just timesing by 1, and you can do that because you can, timesing things by 1 won't change anything. Beautiful. So what that equals is, I'll just go over here, that will be 3/5 sine of 3x over 3x. Beautiful. So now let's approach this. So this is what we're after. We wanted to work out what this was here. So what's your favorite color, guys? Just a little cheeky pink. All right, so limit as x approaches 0. Limit as x approaches 0 of, what was it? It was sine of 3x over 5x. Sine of 3x over 5x. Beautiful. So that equals, now we've just worked out an equivalent expression for that. So that'll be the limit as x approaches 0 of, now instead of this sine of 3x over 5x, we can just sub in, so the sine of 3x over 5x we worked out equaled this. Beautiful. So let's just sub in this for sine of 3x over 5x. So that would be 3/5 sine of 3x over 3x. Cool. So now we can just take this 3 over 5 out the front. So what we're going to do there is, because it's the limit as x approaches 0, this isn't going to change, as this isn't dependent on x at all, because it's just a number. So we can take that out the front. So it's going to be 3/5 times the limit as x approaches 0 of sine of 3x on 3x. Now this is the real meat of the question. Remember, so this is the main concept we're going to use. And remember that the limit of sine of ax over ax, where a is just some number, in this case a is 3, equals 1. So the limit as x approaches 0 of sine of 3x over 3x is going to be 3/5 times 1. Too easy. And now we're just going to, so that is obviously 3/5. Beauty. So what I would do to check this is I'd sub in 0.001 into this thing, and because that's as x approaches 0, and you're going to get something very close to 3/5 just to, just that's a good way of checking you're right. Alright guys, I hope you enjoyed that one, and we'll be back right after the break.